Today we are going to learn on how to solve problems involving the application of second-order ODE. This is the objective of our lesson. Hopefully, by the end of this session, you are able to solve problems involving the application of second-order ODE, which are vibration problems and RCL circuit problems. To solve the vibration problems, you need to apply the mechanical vibration model, which is given by md square x over dt square plus c dx over dt plus kx equal to ft, in which m here is the mass of the spring, c is the damping constant, k is the spring constant, and ft is the external force. Take note that this equation is referred to second-order linear ODE. The system is said to be free vibration when the external force Ft is equal to 0. Otherwise, it is said to have forced vibration. For the undamped free vibration model, both Ft and C are equal to 0. Therefore, the equation is m d square x over dt square plus kx equal to 0. And for damped free vibration model, only Ft is equal to 0. Therefore, the equation is m d square x over dt square plus c dx over dt plus kx is equal to 0. Take note that these two equations are referred to the second-order linear homogeneous equation. For undamped forced vibration, only C is equal to 0. Therefore, the equation is m d square x over dt square plus kx equal to ft. As for damped forced vibration, the equation is m d square x over dt square plus c dx over dt plus kx equal to ft. Both equations here are said to be second-order linear non-homogeneous equation. Now, refer to example 25. The equation of a body performing damped free vibration is given by d square x over dt square equal to negative 20 dx over dt minus 64x. Solve for x given that x is 0 and dx over dt is 0.6 when t is 0. To solve, you need to rearrange the homogeneous equation first to d square x over dt square plus 20 dx over dt plus 64x equal to 0. Next, determine the characteristic equation, that is by replacing d square x over dt square with m square, dx over dt with m, and x with m naught. You will get m square plus 20m plus 64 equal to 0. Solving this quadratic equation, you will obtain the m values, which are negative 4 and negative 16. As the m values are real and distinct, therefore, the general solution to the given second-order linear homogeneous equation is x equal to c1 exponent of negative 4t plus c2 exponent of negative 16t. Differentiate, you will get dx over dt equal to negative 4c1 exponent of negative 4t minus 16c2 exponent of negative 16t. Given that x equal to 0 and dx over dt equal to 0.6 when t equal to 0, Substitute this information into the equation of x and dx over dt that you have obtained and simplify. You should get C1 equal to 0.05 and C2 equal to negative 0.05. Substitute these two values back into the x. That is how you get the final answer, which is x equal to 0.05 exponent of negative 40 minus 0.05 exponent of negative 16t. Now, refer to example 26. The equation of motion of a body performing undamped forced vibration is given by d square x over dt square plus x equal to 3 cos 2t. If initially, when t is 0, x is 0 and dx over dt is 0, solve the equation for x in terms of t. This is referred to second-order linear non-homogeneous equation. To solve, you need to find the answer for the xc first. Determine the characteristic equation. You will get m squared plus 1 equal to 0. Solving this equation, you will obtain m equal to plus minus I, which is referred to complex roots. Here, a is 0 and b is 1. Substitute into the formula, you will get the answer xc equal to exponent of 0x multiply with c1 cos 1t plus c2 sin 1t, which can be simplified to c1 cos t plus c2 sin t. Next is to find the answer for the xp. Given that Rt is equal to 3 cos 2t, which is referred to a trigonometric function. By assuming that xp equal to a cos 2t plus b sin 2t, differentiate, you will get negative 2a sin 2t plus 2b cos 2t. Differentiate once again, you will get negative 4a cos 2t minus 4b sin 2t. Substitute this into the original equation, equate the coefficient of the same variable, and simplify. You will get the answer A equal to negative 1 and B equal to 0. Therefore, the answer for xp is equal to negative cos 2t. Plus the two answers xc and xp, you will get the equation of x in terms of t, which is xt equal to c1 cos t plus c2 sin t minus cos 2t. Differentiate, you will get x prime t equal to negative c1 sin t plus c2 cos t plus 2 sin 2t. Given that when t is 0, x is 0 and dx over dt is 0, substitute this information into the equation of xt and x prime t and simplify. You will get the answer c1 equal to 1 and c2 equal to 0. Substitute these values back into the equation, you will get the final answer, which is the equation for x in terms of t is xt equal to cos t minus cos 2t. Let's proceed with the second application of second-order linear ODE, which is RCL circuit problem. The simple RCL circuit shown in the following figure, which consists of four main components, which are resistor R in ohm, capacitor C in farads, inductor L in henries, and electromotive force E in volt. To solve the RCL circuit problem, you need to apply the Kirchhoff loop's law equation, which is L multiplied with d square q over dt square plus R multiplied with dq over dt plus 1 over C multiplied with q equal to E. Refer to example 26, an RCL circuit connected in series with a resistance of 4 ohm, a capacitance of 1 over 26 farad, an inductance of 1 over 2 henries, and electromotive force E equal to 16 cos 2t. Assuming there is no initial current and no initial charge on the capacitor, find an expression for the charge and the expression for the current at any time t. Substitute the information of R, C, L, and E into the equation of Kirchhoff's loop law. You will obtain the equation 1 over 2 multiplied with d square q over dt square plus 4 multiplied with dq over dt plus 26q equal to 16 cos 2t. Simplifying this equation, you will obtain d square q over dt square plus 8 dq over dt plus 52q equal to 32 cos 2t. As this is referred to second order linear non-homogeneous equation, you need to find the answer for the qc and qp. First, determine the answer for the qc. By letting the function on the left equal to 0, you will get the characteristic equation m squared plus 8m plus 52 equal to 0. Solving this equation, you will obtain the answer for the m, which is equal to negative 4 plus minus 6i. This is referred to complex root. Therefore, the answer for the QC is equal to exponent of negative 4t multiplied with C1 cos 60 plus C2 sin 60. Let's proceed with the answer for the QP. Given that RT is equal to 32 cos 2t, which is referred to a trigonometric function, by letting the QP equal to a cos 2t plus b sin 2t, differentiate, you will get negative 2a sin 2t plus 2b cos 2t. Differentiate once again, you will get negative 4a cos 2t minus 4b sin 2t. Substitute these values into the original equation. Then equate the coefficient of the same variable and simplify. You will get A is 1 over 3 and B is 1 over 9. Substitute this value back into the QP. You will get the answer for the QP is 1 over 3 cos 2t plus 1 over 9 sin 2t. Plus the two answers QC and QP, you will get the equation of Q in terms of t, which is exponent of negative 4t multiplied with C1 cos 60 plus C2 sin 60 plus 3 over 5 cos 2t plus 1 over 5 sin 2t. To find the equation of I in terms of t, you need to differentiate the answer for the Q with respect to t. You will get exponent of negative 4t multiplied with negative 6c1 sin 60 plus 6c2 cos 60 minus 4 exponent of negative 4t multiplied with c1 cos 60 plus c2 sin 60 minus 6 over 5 sin 2t plus 2 over 5 cos 2t. Take note that this is not the final answer because you need to determine the value of C1 and C2 first. As stated in the question, there is no initial charge and no initial current. Therefore, when t is 0, q is 0, and I is 0. Substitute this into the answer of q and I with respect to t and simplify. You will get the answer for C1 is equal to negative 3 over 5 and C2 equal to negative 7 over 15. Substitute this value back into the equation of Q and I with respect to t. That is how you get the following answers. With this, we finish the whole syllabus of MAT 235. Alhamdulillah. So in the next lesson, we are going to do revision on chapter 4, that is on ODE. Till we meet